Assalamualaikum and a very good day to Doctor. My name is Putra Hamizan bin Kamarizal. My matric number CE230020. Today I'm gonna presenting about project. Okay, this is our group member. Okay, the first one is Muhammad Afiq bin Sapawi, number matric CE230060, and me, Putra Hamizan bin Kamarizal, number matric CE230020, and the third is Muhammad Amirul Helmi bin Saudin, CE230058. Okay, for this agenda, the contents include introduction, method, result, discussion, and conclusion. Okay, for introduction, a graphical programming environment called Simulink is used to model, simulate, and analyze dynamic system with multiple fields. It is a component of popular numerical computer environment and programming language MATLAB. Block diagram modeling of dynamic system is made possible by Simulink. So for this project, we have to use MATLAB Simulink software to design an electrical circuits and determine the voltage of each circuit node as indicated in figure 1, modify the circuit. So for the method, we can gain skill and information required to utilize Simulink for circuit design and analysis to its fullest extent by workings on this project. So we got 6 method, which is first circuits design in Simulink. So for circuit design and Simulink, begin the launching Simulink environment, create a new Simulink model and set up the circuit component as illustrated in figure 1. Use a proportionate block for resistor, voltage source and current source to model the circuits accurately. Okay, for the second one, nodal voltage analysis. Uh, it is to employ the Simulink analysis tools to calculate nodal voltage, integrate appropriate voltage measurement blocks in circuits to capture nodal voltage value at the desired location, configure simulation getting to ensure accurate and efficient analysis. The third one, parameter variation. The parameter variation defines parameter which is R, V, and A as variable in Simulink. Model utilize MATLAB, scripting or Simulink parameter variation tools to, systematically vary this parameter. Conduct simulation for different parameter sets, ensuring a comprehensive exploration of a parameter space. Number 4, data compilation is to record a nodal voltage value obtained from each simulation run. Organize the data in the table format with column representing different parameter set and rows indicating nodals, voltage, and various points in the circuit. And number 5, visualization. We use Simulink plotting tools or MATLAB script to create a visual representing of the data, such as a graph or a chart to enhance the clarity of finding. And lastly, sensitive analysis. It is to perform sensitivity analysis to understand the relative influence of each parameter on nodal voltage, identify critical component or condition that significantly affected circuit's behavior. Okay, that's all for me.
Hi, my name is Muhammad Amirul Helmi Bisaudin. My metric number is CE230055. So I will present about lab 4 project. So based on the question, uh, we have to use MATLAB Simulink software to find a nodal voltage of the circuit as shown in figure 1. Then we have to analyze circuit by varying the value of resistor R, voltage V, and current A source. So for the simulation. This is our circuit. So you can see that uh, this is the current control voltage source. This is for dependent voltage based on dependent voltage source. So if the Ix value is changed, so this value also will change. Uh, the trunk resistance K is 10. So the Ix value will multiply with tens. So the voltage source is 4. The voltage source is 10. Uh, then the current source is 5. For this value of resistance, we put 2, same as the lab 3 question and lab 2 question. So if we solve by lab 3 code, we put if we put 10 for voltage, 5 for current, and 2 for resistor, we will get V1 is 18.116, V2 is 17.9185, V3 is negative 22.63, and V4 is 10. So if we look at the circuit that's simulating after I run, we can get the V1. The value is 18.11, same as the lab 3, 18.11. For V2 is 17.62, 92, same goes as lab 3. The V3 is also same, negative 22.64, and the last one is V4 is 10. So Ix, how to get Ix? The Ix value is V1 uh, minus with V4 divided by 2. If I solve using the code, this one, if I run, we can get Ix is 4.0558. Same at this simulation. Okay, that's all from me. Thank you.
Assalamualaikum and good evening, doctor. My name is Muhammad Afiq bin Safawi and my message number is CE230060. So I will continue from my team member Helmi the presentation about the simulation. So for the result, we will start by using the value from lab 2, which is voltage is 10, current is 5, and resistance is 2, done by Helmi earlier. Then all the values that have been stated earlier will be added by continually for 7 times to show the difference in value for each different parameter to the nodal. So we change the value of voltage, current, and resistor to the circuit. So table 2, so voltage and current resistor is 11, 6 and 3. So for the voltage and nodal we get 23.42. Voltage and nodal 2 we get 19.98. For the voltage and nodal 3 we get negative 21.43, and for the voltage and nodal 4 we get 11. So for the value of Ix, which is we got 6.210 ampere. For value of dependent voltage source we get 62.10. So for the table for the number 3, which is voltage, current and resistor, is value 12, 7 and 4. For the voltage and node 1 we get 28.79, and the node 2 we get 21.98, and for the node at 3 we get negative 20. So for the voltage at node 4, we get 12 volt. For the value of Ix, we get 8.395. So value of Ix, we got from V1 minus by V4 divided by 2. So for the value of dependent voltage source, we get 83.95. So the rest is for the table 4, 5, and 6. Next is discussion. So for the in our solution, we observe that increasing resistor value result in higher voltage drop and lower nodal voltage downstream, following the Ohm's law. So nodal voltage are directly affected by change in voltage source values, rising proportionally with increased sources. The overall energy distribution in the circuit depends on these voltage sources. So change in current source impact overall current distribution and consequently nodal voltage. Higher current source lead to greater voltage drop across the resistor, influencing nodal voltage. The simulation validate our simulated model by closely matching theoretically calculations for non-parameters, ensuring accurate representation. For the simulated feasibility, allow easy parameter adjustment, beneficial for sensitivity analysis on the circuit's behavior. It is integration with MATLAB simplifies incorporating analytical calculation into simulation. So in charging the overall understanding of the circuit behavior. So for the time domain simulation, we simulating enable us to study the circuit transient response over time, especially useful for analyzing extraction to input changes. For our conclusion, the project effectively designed and analyzed an electric circuit using MATLAB simulating program with an emphasis on nodal voltage under different resistor, voltage and current source values. The result provide important new information for circuit design and optimization by eliminating the complex interaction between circuit elements and factor. By comparing the simulated model's result to theoretical calculation, trust in the accuracy of the result was increased. The present effort is established the groundwork for more investigation into the intricacy of electrical circuit and function as pragmatic manual for engineers who want to comprehend and adjust nodal voltage for certain purpose. That's all from our group. Thank you.